then it should be like motional EMF, that is going to be induced electromotive force, that is normally represented a type of capital E is equal to VLB. What is L? L is the length of the conductor, B is the magnetic field, and velocity V is with which the conductor is moving. And what was the diagram that I would like to explain all of you over here once again, because ultimately in this class we are going to deep inside this conductor to analyze the cause. Fine. So let us say this is x axis, this is y axis, and over here these yellow cross marks are showing you the magnetic field, fine, which is right now present perpendicular to this green board inside, that is the symbolic representation. So what I can say that B is nothing but B naught, let us say any value, and minus K cap, that is unit vector K. So now the direction, the magnitude, and the this graphical representation both are present. Now let us say I have a metallic conductor, fine, this way. I have this blue color metallic conductor, or you can say a metallic rod, that is why I am showing it like this way. So this is a metallic conductor having length this is small l, fine, and it is moving with velocity v. So how you can define this v? You can simply mention v is equal to v naught, any value, fine, and I cap. So now I hope this simple explanation of this formula which we already learned is clear to all of you. As per my promise which I made during the discussion in the first video of this topic, now I am going to explain how exactly you can analyze that what exactly happening, what is the cause, what is the source of this character of this movie, what exactly, from where it is coming, fine. So now please try to understand. Let me allow to break this entire setup in two diagrams, fine, and here I am going to utilize one of the concept of class 11th, that is reference frame. So let me allow to break this diagram in two parts. Let us say I have this one part as S frame, this is S frame, and in this S frame this magnetic field is present, fine. Another I have this, let me allow to draw another diagram, that is this blue color, and let us say this is S prime reference frame, fine, and in this reference frame this rod, metallic rod is placed. So now you have two reference frames, one is in which this magnetic field is attached and another in which this rod is placed like this. Practically you can imagine the situation in this manner. Let us say I am sitting in a car and this is a metallic conductor, this blue color, and I am sitting in the car on the back seat and the driver is driving the car, let us say in east-west direction, and magnetic field is present perpendicular to my direction. So for me this rod is always in rest, the position of this rod is not changing because always it is in front of my eyes, in my hand. So this is S prime frame, and this diagram, because the magnetic field is present perpendicular to my car's motion, so this is something which is the S frame. So you have to imagine in this situation, fine. Now I had to write down the electric and magnetic fields associated with these two reference frames. What exactly the situation? Please take a look over here. This magnetic field is present which I am showing with the help of a diagram, But if I am saying electric field is also present, then few of you may think from where the teacher is saying electric field is present. Okay. So, for all of those students, please, the velocity v and magnetic field B perpendicular to each other, no doubt in it, that is why I mentioned like this. And obviously, if B and B are perpendicular to each other, so because of this motion a force will act, and this force will do what? This force will ultimately forces the electrons to move in one specific direction. So, in this situation, using right hand rule, I can say that the direction of accumulation or motion of electrons is in this segment, fine, and accordingly positive charge accumulation will take place, and this is something which is happening inside this metallic rod or metallic conductor. So, because of the accumulation of positive and negative charges, if I am saying that an electric field is existing with this type of charge accumulation and distribution, you will say yes, exactly, it is existing. So, what about this electric field values in S frame? What about this magnetic field value in S prime frame or in S frame, or this E value in S prime frame? So, now we are going to write down those values. Ultimately, we are interested to find out how it is coming out, and the basic idea that we want to utilize is nothing but, if I am saying this type of relation, fine, over here this is electromotive force or potential, this is electric field, and this is the length of this metallic rod. So, first I am going to write down the expression of electric field for S prime frame. This is present over here with the blue color notation. So, over here Ex prime is equal to, Ex prime means x component of electric field in S prime frame is equal to Ex is equal to 0. Simple. Then Ey is equal to, that is, let me write down over here the same reference frame, Ey prime is equal to, now I want to write down the y component of electric field associated with this presentation, fine. So, it is going to be Ey minus Bz over a factor under root 1 minus V square upon C square. Now, many of you get quite problem in a situation, what exactly the meaning of 1 minus V square upon C square, from where we are introducing this term? Relax, simple. Actually, when any charged particle is moving, fine, then try to recall some concepts that I am sure you must have studied somewhere, or you are supposed to study in your electromagnetic waves. This is something which is given by great scientist Einstein during the explanation of theory of relativity. So, that is something we are getting over here, fine. It means this Ey prime component is going to slightly reduce. Why? Because of the presence of this parameter. This is the practical aspect that we are trying to write down. Now, please try to write down the values. Over here, V is B and Bz is what? Please take a look over here. Bz is nothing but minus B naught K. So, this minus and this minus sign will ultimately give you a plus sign. So, let me allow to write it down in this fashion, that is Ey prime. Ey is nothing. So, it is going to be, because as such no electric field associated in the y direction. So, it is going to be BB naught upon under root 1 minus V square over C square, fine. Bz means this value, that is B naught. Then I will write down Ey sorry, Ez prime. Now Ez prime means the value of Z component of electric field associated in this reference frame. So it is going to be Ez, as usual the way I am writing, Ex, Ex, Ey, Ey and so on. So Ez is equal to, oh I am sorry, it is going to be Z. Ez prime is equal to Ez plus By upon under root 1 minus V square over C square. Now if you take a look of this parameter, then it is quite clear that value of By is 0. So ultimately what I should say, that Ez prime is equal to 0. Once again I would like to request all of you, these are the values of you can say electric field components X, Y and Z associated with this rod in S prime reference frame. Fine. Now I would like to write down the magnetic field in this reference frame. So over here, just to make things simple for you, what I can say, that Bx prime is equal to By prime is equal to 0. Reason being, as such no component of magnetic field present in what, X direction and Y direction. Now for Z direction, let me allow to use this space itself. Fine. Over here I will use. So it is something which I am going to write down in terms of Bz prime. The expression is applicable from this reference frame, that is S prime. So it is going to be minus B naught upon under root 1 minus V square upon C square. So now ultimately I explained all the electric and magnetic field components for this reference frame S prime. Fine. Rather than consuming your lot of time for writing these equations, few things I would like to explain you in simplified fashion. Similarly, you can write the values of electric and magnetic field for this reference frame also. Fine. Over here please consider one fact. In this reference frame, this conductor is stable, not moving. Imagine I am sitting in the car holding this rod in my hand. So with reference to me, with reference to the driver of the car, this rod is not moving. So magnetic field values are same everywhere. Fine. And inside the conductor, in this conductor, let me write down the values of Ex, Ey and Z. So what I can say, inside, and that line I am not writing. Fine, simple thing, because the rod is stable, the conductor is stable, so magnetic field is everywhere same. Inside the rod, Ex prime, Ey prime, Ez prime is equal to 0. Now please don't get confused that one side I am saying Ey prime, Ez prime and so on, and one side I am saying Ex prime and all these 0. This is for inside the conductor. So let me underline this sentence, inside, and this is something which is happening outside. So also you know from Gauss law, inside a conductor no electric field. An electron is moving in a circular orbit of radius capital R with an angular acceleration alpha. I hope the first line itself giving you the clarity of the diagram or the situation. At the center of the orbit is kept a conducting loop of radius small r. Obviously, small r is very less than capital R. The EMF induced in the smaller loop due to the motion of the electron is how much? Now the question is simple, and I just tried to use a basic concept of revolving electron to explain this problem. Now what I will do, the question is present over here, I will use this space to explain the situation of this particular question, and after that also certain aspect. Fine. So, let us start the solution of this problem. I will only mention the required steps, and in this explanation, if some portion of the questions are not visible to you, I hope you will not mind it, because here I am giving you the proper explanation. So, this is the question. Now, let me allow to present over here, and this is the formula required for the solution of this problem, that is A dB upon dt. Now, A is equal to pi r square, you know that circular area. So, what I will do, this B is something that is given as, directly I am writing the formula, that is mu naught upon 4 E r square alpha upon r. Now, few of you will start thinking, what exactly the expression of the B? If any one of you is thinking like this, my simple suggestion is, please go through with the videos of this particular chapter once again. But here I am going to help you out. I will mention the value of V. Fine. So, the value where B is equal to mu naught upon 2 into q omega upon 2 pi r. I hope now the entire explanation is clear to all of you. So, on the basis of this mu naught upon this particular expression, B is the correct option, that is mu naught E r square upon 4 r into alpha. So, this question is a basic simple question. Fine. Now, I have to move ahead. So, let us clean this board so that we can get ready for next problem for the discussion. So, here comes your question number 2. Now, this question is not a difficult one, just because of the language this question is long, otherwise it is a simple question. A square wire loop, you need not to imagine anything, everything is mentioned in this diagram, of 10 centimeter sides lies at right angles to a uniform magnetic field of 20 Tesla. I hope small some these crosses are visible to all of you. This is just a representation of the magnetic field perpendicular to this green board inside. Fine. A 10 volt light bulb is connected in series with the loop as shown. The magnetic field is decreasing steadily. It means magnetic field B is starting from a top value reducing to 0 in delta t time. Okay. The bulb will shine with full brightness if delta t is equal to time interval, means maximum current will flow after how much time, that exactly your problem. This particular question is nothing but based upon the formula which just 2 minutes back I explained for the first question. So, let me allow to write all these formulae once again for the solution of this problem. Del B, sorry, it is A dB by dt. Who is changing with respect to time? This B is changing. Fine. So, what I can write down, that this dt is equal to A dB upon, no problem, simple, you have to find out delta t. So, all other values are given. Putting values from question as given. So, I am not taking a lot of time. Putting values from question, fine, once you solved it, so delta t you will get at 2 millisecond. second. Putting values I am just leaving, because there is no point of putting the values and solving this multiplication, division, etc. Important is concept. Now forget each and everything, just concentrate over here. Okay, this is your crux of the matter. If this formula is clear to you, then whether V is changing, whether A is changing, induced EMF will come into picture. Fine. So my emphasis by using these two questions is simple. I want you should know this formula, that's it. Because in this entire chapter there are just few formulae. Okay. So now let me allow to clean this board and we will move ahead for the discussion of next problem. So here comes your question number 3. Now the magnetic flux, magnetic moment, this sentence comes into your mind, phi B is equal to B A cos theta. This formula should come in your mind anyway. With resistance R varies during interval of time t as phi is equal to AT into T minus T. The heat generated during this time, neglecting the inductance of loop, will be how much? Ultimately in this question also they are asking about induced EMF. Only then you can find the heat H is equal to I square R T type of relation. Okay. So from here we will start our discussion of this topic, I mean this particular question. Now once again the same formula but in a different manner, that is equal to d phi B by dt. What you have to do? Differentiate phi with respect to time t once. That easily you can do. Although you are preparing for medical entrance exam, but I know, I can understand that small steps in integration and differentiation, very simple, you can do that. Okay. So from here after this what I can write down? I can write down after differentiation it as AT minus 2AT. Fine, this is something which we can write down, AT minus 2 small t, rather not capital T. Fine. From here heat generated is heat H, class 10th formula, I square RT. So same type of thing we will do. And how exactly we will do that? That is square R dt. Fine. Put the value of this square and differentiate it. So simply what I will write down, after solving. Now even if you picked previous year's question papers of NEET medical entrance exam, you will find at least around 20 to 25% questions have some sort of calculations. Not very difficult, but yes, some steps are there. So that's why I am putting these questions. Now after solving, obviously integrating and solving it is not a big task. Fine. So first is differentiation involved, then integration. So answer is going to be a square t cube upon 3r. So if you just take a look of this expression, from here you can easily say that a square t cube upon 3r, that is a is the correct option. Now with this question what I want to prove, what exactly my motive is? Simple. In one question I used integration and differentiation both. Fine. Also I use this formula in a different aspect. My motive is clear. Number one, these basic mathematical tools, utmost important. Please just make yourself comfortable with these small steps. Number one. Number two, you should know if I am going to do some sort of makeup with any specific result, then what exactly the resultant result that will be come out. Fine. So there is a twofold motive for this particular problem. and I hope you will appreciate this effort where I am putting so many situations in front of you so that you can easily revise your basics for the understanding of the topic. Now here comes question number 4. Well, this question is out of 45 questions in physics, you will find 4 or 5 questions are so difficult, so long, so complicated, while it is not truth. If this type of question is given, then obviously a medical stream student 90% what they will do, oh my god, let us move ahead. I want to change this habit. Please, it is not like that. Try to understand the problem. In a cylindrical region having radius r, this one is, magnetic field varies with time as B is equal to A plus Bt. If the concepts are clear, understanding this line is not a problem. With time the magnetic field is changing. So, ultimately changing magnetic field producing this induced EMF. OPQ is a triangular loop made up of wire having resistance per unit length lambda. Find the current induced in the loop. Fine. Question is simple, diagram is given. Now I am going to explain you how to find out. Okay. So, just take a look properly. Triangle OPQ. OPQ. I am writing over here. I am repeatedly saying about this explanation. You just have to listen and take a look over here. If required and diagram is visible, you can quickly take a look of the diagram also. Triangle OPQ, PQ is equal to root 3R. This is something which is based upon the basic algebra, and OQ is equal to 2R. Fine. So, these two values. Now, as such there is no difficulty in understanding this situation, but I mentioned, I hope now it is going to the part of your video. So, you will repeat it, revise it whenever required. Take a look of this diagram, triangle is clear and the values are given, this angle is 60 degree. Now, I am cleaning this portion, okay. It was initial introduction. Now, resistance, what I am trying to do, I am making these explanations as simple as possible. In this particular question, whatever I mention using basic algebra, you will say, oh, no problem in that, fine. Now, resistance of what? Resistance of loop OPQ, fine, because it is a wire having resistance lambda per unit length. So, resistance of loop OPQ is equal to lambda and then total length, fine. So, lambda and 3 plus root 3R. Yes, I think I should write this R with a different color, R, fine. So, this is the total length of this, that you can say, take it out common like root 3 lambda R root 3 plus 1. This is something that you can, any point of time you can do that, okay. Now, this is nothing but arranging the terms. Now, I induced is equal to A by R dV by dt. As such, now even my support is not required. I hope after this much easily you can put the values of B, differentiate it, and you will get the resultant as I induced is equal to pi R B root 3 minus 1 upon 12 root 3 into lambda.